welcome to another episode of the Engineering Side of Data. I'm your host, Bob Hafner, and we're going to be talking about analytics engineering today. And I have a special guest that's going to help me do that. Her name is Kelly Burdine. Kelly, can you introduce yourself, please?
Yeah, absolutely. Thanks for having me, Bob. I am the data lead at a ed tech software company. I lead a team of 4 other individuals, and we are focused on providing internal data analytics support for our organizations so that we can make better decisions, better data-informed decisions, as well as building analytics products into our actual software. Prior to that, I've worked as the senior analytics manager at another software company for roughly 5 years. And prior to that, I've worked as a data scientist in a couple other organizations as well.
All right, thank you. All right, let's just jump right into it. What is analytics engineering? What does it mean to you?
Yeah, so the term analytics engineering has only been around for a few years, but I think the role itself has been evolving longer than that. And so if I had to kind of quickly sum up what an analytics engineer is, I would say that this is a person that is focused on cleaning, transforming, and preparing data for use in analytics and maintaining all of the documentation and the testing around that data. And there's someone that, it's kind of a combination of bringing analytics and software best practices together, is kind of how I would describe the overall skill sets of this person. And so the way that, this, like I said, this is kind of a newer term, analytics engineering. It didn't used to exist, but it's been evolving longer. And I think that, with the rise of big data and a lot of the newer technologies out there, that's kind of where this role has come from.
Oh, excellent. And I imagine the need for it as well is driven by deadlines, a sense of urgency, and some of these tools have enabled the analytics engineering to happen in the first place, right?
Yeah, you're absolutely right. So, if we think back to, even early 2000s, a lot of companies were still operating with, on-prem databases and, things like SQL Server, Oracle, those were really common. And so there was a hardware aspect to, being able to maintain these databases, and the databases themselves didn't scale very well because you had to replace hardware, and they're also things like SQL Server and MySQL and Oracle, were really like row-based databases. And when you think about that works really well for applications, especially when you're talking about transactional data and being able to store and update rows of data very quickly in records. But when you're talking about analytics, that really is not an optimal way to store data. It's often very slow to be able to query that data for use in analytics. Very rarely are you just looking at a single record when you're trying to analyze data. You're often trying to see, what's the average cost of, an acquisition of a customer or something like that, where you're looking across rows and you're really doing a lot of aggregations on the columns. And so, I think with that, and people wanting to use data and leverage data for better decision making, came about a lot of new tools, and cloud computing was a thing as well. And so now there's these cloud data warehouses out there, like Redshift was probably one of the first ones. You have Snowflake, BigQuery, Azure, even Firebolt now are some of the most common kind of big parallel processing cloud computing data warehouses that are really designed for analytics. And so things became a lot easier to scale, a lot cheaper to store data. And because of that, we found that organizations were capturing and storing a lot more data. And you didn't need to transform it all before it went into the warehouse. Before, you really had to transform that data first, because trying to transform it in that row-based database was very costly. And and so now you can store all this raw data, you can collect tons of it, it's cheap to store, you can just kind of throw it all in there, and you're like, great, now we have so much more data that we can leverage to make better decisions. And like you said, with the urgency, it's, that's great. Now we can get to data faster because we don't need to transform it first. We can just load it all in there. And so this new opportunity was created, which is great. But with that becomes new challenges as well. And so, I think, I don't remember who said it first or what article it appeared in. I think it was, Forbes or something like that, where they said data science was going to be the sexiest job of the 21st century. And so all these companies went and hired data scientists and said, great, we have all this data. Now you can go, analyze it and create these great insights and predictions and tell us, what to do. But what happened was you have all this vast amounts of raw data, sometimes even unstructured, and it's messy. It's really messy. It's not easy to analyze that data and to pull out insights when it's riddled with caveats and things are not named right, and you don't know when it was last updated, and so it's just messy.
Yeah. And it certainly isn't fit for use by business users, right? Maybe some of that granular or some of that dirtier data could be used by a data scientist or an analyst perhaps, but definitely not suited for the business unit in the corner office for sure.
Yeah, you're absolutely right. And this is where, analysts would end up spending tons of their time just cleaning data. Just, I think there was this estimate out there that, 80% of an analyst or a data scientist time was spent just cleaning and prepping data, and only 20% was really analyzing and kind of driving insights and decisions. And that's not really what you want, right? Because that's not where you can save money. That's not where you're going to gain a competitive edge, is the cleaning of the data. And it was really difficult to do. And so this is where the analytics engineer sits, is they can go in and take this data and they can transform it and clean it in a very efficient manner with some of the tools and best practices that are out there now, and to prep it for not just analysts, but like you said, business users, that they can go in and use BI tools that are, point and click. No longer do you need an analyst to set up a basic dashboard. You have your product manager or your business, the head of business or your head of marketing can go in there into this dashboard, and the data is cleaned. It's designed in a way that works in a point and click BI tool, and they can very quickly visualize what's going on.
Excellent. Now, it does sound like analytics engineers and data engineers perform similar tasks, or at least the end goal is similar. What do you think separates the two roles?
Yeah, this varies a little bit by company. But I would say, an analytics engineer is really focused on, we often hear ETL, which is extract, transform, and load. So we're extracting data from various data sources. We are transforming it and we're loading it to the data warehouse. And I mentioned earlier that, we no longer need to transform it before it goes into the warehouse. We can kind of load it and then transform it. And that's been probably a more common practice with modern data tooling. So it's more of like an ELT than an ETL. And the analytics engineer is really focused on that transformation layer, I would say. However, they can still extract and load data. There's a lot of great tools out there that, with either low code or no code, you can extract and load data from common data sources. So things like Salesforce or Marketo or HubSpot, these very common SaaS products that are used by tons of companies out there. You're loading the same type of data, so it doesn't take an engineer to write a custom extract and load script for something that everybody else is loading. And so there's these great tools out there like Fivetran and Stitch that basically come with out-of-the-box solutions. And so analytics engineers will often leverage those types of tools and pull that in themselves. So in some organizations, you might not even have a data engineer. An analytics engineer can really cover that entire ELT process. But when it comes to custom scripts or different data sources that you might need to load in that don't come with an out-of-box solution, that's often where your data engineer fits in. And there's also, it depends a little bit on the organization, but when you are deploying machine learning models, depending on how big your company is, you may have a machine learning engineer that deploys those, but it might be your data engineer that figures out how to, process those large amounts of data and, run the model in production and deploy it and everything. So it does vary by organization, but I would say generally the data engineer is more on the side of extracting and loading data and building more custom solutions when necessary. And the analytics engineer is more focused on the transformation and the front end process of analytics.
Okay, makes sense. Yeah. When I think of analytics engineering, I generally associate that to batch-oriented warehouse style things, right? Is that what you think of? Are there other, use cases or, pipelines or tech that they're involved with?
Yeah, I would say that is more common, the batch-oriented data warehouse and loading data, a few times a day or even just once a day sometimes. That's probably the more common thing. And certainly analytics engineers are generally really good at that. When it comes to, streaming data and setting up things like Kafka or Kinesis or, other streaming pipelines, I'd say this is probably a less familiar area for analytics engineers. There's some out there that can do this, but it's probably not their bread and butter. That's generally going to be more on the data engineering side of things. However, tools like Snowflake and I think Firebolt even are advanced enough that they are allowing for more frequent updates in the data. So I think when Redshift first kind of evolved, it was very much like I would call it like a batch only oriented data warehouse because your storage and compute were coupled together. And so every time you're loading data into the data warehouse, that is taking up compute resources from being able to query it. And also you kind of had to scale it with the storage as well. And so it made it a little bit more difficult. It kind of put the data warehouse on the sidelines as you were loading. So having a continuous load of small amounts of streaming data really didn't work very well, to be honest. And but now, other tools have kind of upgraded, I guess, their systems so that they can handle this.
I got you. It makes it a little easier for the ingestion and the transformation to continue working alongside of serving up data for users, right? I would imagine, right? So they've kind of figured out a way to do those micro batches so you can get that streaming.
Exactly. So exactly. You can have different servers within the same warehouse for different jobs. So you can have one server for loading data, another for transforming, another for querying. And you can have a whole bunch all assigned in there. And so you can really separate out the different compute resources to allow for that. And some of these tools even come with kind of built-in, I'll call them hoses, if you will, to kind of ingest the streaming pipelines. So we're seeing the tools evolve and get better and better at this now.
Excellent. You've mentioned a couple of the tools in the analytics engineering tool belt, right? So, and they've been mostly commercial. Is there open source tools in the analytics engineering world?
There's actually a lot of really, really great open source tools out there. I think the primary one that comes to mind, especially when you think of analytics engineering, is DBT. And this is just a wonderful tool out there to use to transform data. And the idea behind DBT is that, every transformation is written in SQL, which is the language, the primary language of analytics engineers. And so each transformation can run as like a separate SQL script, and they're all connected with dependencies in like a directed acyclic graph, a DAG. And there's testing and version control and a lot of other great features of DBT. And there's a wonderful open source community that helps, maintain this tool, and has allowed it to grow exponentially over the last, I'd say, like 5 years. And so that's a really great open source tool out there. And then there's other ones as well. Things like Airflow and Luigi are tools to help schedule and orchestrate jobs. Those are both open source. There's newer ones out there like Dagster and Prefect as well. And even load jobs. So there's I mentioned Fivetran and Stitch, which are commercial tools, but there's actually Stitch, for example, uses like Singer taps, and Singers, you can build those open source. You can leverage those. And there's a newer one out there called Airbyte, which is a similar idea. There's open source, and it kind of gives you the tools to be able to, kind of half custom build, I guess, your extract and load jobs, if you will. So there's tons of really great open source tools out there. So I tend to, when I'm evaluating, a gap in tools, to actually look at the open source first and see what's out there.
Oh, excellent. Yeah. And I recognize some of those tools you mentioned, Airflow, Dagster. A lot of those are starting to have, I guess, extensions or partnerships with DBT. DBT is a very popular tool, not only in the analytics engineering, but they have some big fans in data engineering as well. So it's and I didn't know about Singer. So that is the open source kind of Fivetran version where you get the benefits, I would assume, of having something out there that has taps or connectors to a lot of popular data sources, so you don't have to reinvent the wheel. That sounds pretty good to me, yeah.
Absolutely.
So you mentioned SQL is kind of the language of choice for the analytics engineer, and it's very popular. And what do you like about SQL so much, and what don't you like about SQL, if there's anything?
Yeah. SQL's great. I love SQL. I mean, it's been around for a very, very long time, and I think there's a reason for that. It's, if you look at SQL, you can almost read it in plain English. It uses very common terms like, select and where and group by. It's very intuitive to read, and, you can run queries very easily with it. So I think from that perspective, I think it's great. Like I said, it's very intuitive. I think it's easy to pick up and understand. Also, it's fairly universal. Like, there's all these different databases are using SQL, and they have their different flavors. Like Oracle, it looks a little bit different. There's different functions available in, say, Redshift versus Snowflake, but it's still fairly standard. And so it's very easy to move from database to database, and you can kind of drop right in and start coding. You don't need to relearn a new language. And so from those perspectives, I think it's actually very, very great. What I don't like about SQL, I would say, well, SQL is a declarative language. So it's not a, programming language like Python or Java, where you're telling the computer this is how I want you to process this in this order. In SQL, you're basically stating like what you want the output of your data, of your query to return to you. And the database itself is saying, okay, I'm looking at what you want it to output, and I'm going to figure out the most efficient way to do that. And so that's great if you're coding in it. You don't have to think about that. But where it can kind of get you into trouble is you can write code in a way that causes bad queries that run for a very long time. And you're not always sure by just looking at the query, like, is it going to evaluate the where first, or is it going to evaluate the group by first? Like, what is the order of operations here? And when you get into a complex query, that can be very, very important in how it's going to process the query. And when you think of things like, parallel processing and how it actually distributes across the nodes, and with sort keys and disk keys and stuff, it can get kind of complicated. And so it takes a few years really of doing it in and out to really understand all that. And so that you always kind of can evaluate a query, like, is this the most efficient way to do it? And so that can be a little bit difficult, and especially because it's so easy to get going in SQL and write a query that returns something. It makes it so anybody can kind of write a query, and and if it's going against your data warehouse and it jams up resources because it's got some crazy cross join that's just running and running and running,
yeah.
That's where SQL can be a little bit bad. It's almost like too easy to get going, and so you can get yourself into trouble
damage,
a little bit.
Right?
Exactly.
My bad query could make a bad day for everybody on the team. So yeah.
Yes. Yeah.
I would agree with you about SQL and it being universal. I think for 90% of the things you write, I think you could probably take that from this database platform to this database platform. And I know that there's those edge cases that things don't transfer over, but I think they are minimal. And I also think that for 90% of SQL things, they do make sense. I would agree with you. They're very intuitive. I mean, maybe you could take a shot at windowing, or maybe dealing with some complex JSON nested types, things like that. But for the most part, yeah, I would agree. It's very intuitive.
Yeah.
So I consider myself a data engineer. And one of the frustrating things, or one of the things I guess I just come to realize, is that there's a lot of different opinions on how to solve problems between data engineers, right? So if you ask 5 different data engineers how to solve a problem, you'll probably get 5 different answers. But my impression is that analytics engineers have, I guess they're more on the same page. Would you agree with that? And if so, could you elaborate on why you do?
Yeah, and I know exactly what you're talking about. I've worked with a number of data engineers over the years, and so I've seen the differences of an opinion. And I would say that, although there's not complete consensus over everything, there is more consensus among analytics engineers. However, it's a smaller community right now, and I think it's a very tight-knit community at the moment, because it's still this emerging career path. And I think the people that have kind of found themselves in this path have all come from dealing with similar pain points and have a similar reason for why they're being there. And those shared reasons have kind of brought them together. And so there's a similar background, which probably is leading to a lot of the consensus there. And so I think that's my best guess as to why that is. I do see that, especially, I'm involved in a couple of Slack communities that are very focused on analytics engineering, and I will sometimes propose a problem that I'm solving, and there will be differences in, like, oh, have you tried this tool or this tool or this tool? But you'll see a lot of the, like, up arrow emojis, like what that guy said. said. And so, yeah, exactly. So I do see that. I mean, I don't think it's complete consensus. There's certainly differences in opinions of tools and things like that. But for the most part, especially around like process, I see that a lot.
Yeah. And I think you touched on it with the community, right? If it's, it does seem to be a very tight community. Maybe it does help that it's small. And then, who's the DBT Labs? Is that right? That's the rebranded Fishtown Analytics. They're
That's
very
right.
active. They're pushing. Hey, they set out maybe patterns or blueprints for certain types of solutions. So that kind of helps out as well. So yeah.
Absolutely.
All right. What does a typical testing process look like for an analytics engineer?
Yeah, it's really not that different from like software engineer testing, especially if you're kind of following best practices in kind of a modern data team. So, for example, my team, I've set up a testing environment. So we have like this production version of our analytics database, and then we have branch versions of that and a testing environment. And so when we need to change the code, let's say we need to add a data model or maybe modify some business logic in our data, clean up a data, whatever it may be, we're using version control. So we use Git and GitHub, and we can make that change. I can test it in my branch schema, and I can test it locally and, verify that it looks good. I push it up to GitHub. We can do a PR review, and then it runs in like the testing environment. And if everything comes back and it passes the run, we have a lot of automated tests built in. And, we usually do PR reviews as well. And then we can actually deploy that change in a, CI/CD environment. So it sounds and looks very much like a best practice kind of software engineering testing setup. And we have unit tests that are written. We have other ways of manually testing things. And we have, like I said, testing environments, branch schemas, version control. So, that's what it looks like. And that's what it looks like for us. And I think it's very similar to many other organizations as well.
Yeah, that does sound very similar. Like if you ask a software engineer how to describe their testing and deployment process, that's exactly what they would say. Hey, let's talk about some career stuff for a second here.
Yeah.
What do you think are the most important skills to learn?
Yeah, so I think we'll start with the technical skills. I mean, we've already talked about SQL a bunch, and that's, you have to learn SQL. You have to know SQL. You have to be, very solid in your SQL skills. I think it's also helpful to have some type of programming language. Python is probably the most common for analytics engineers. So I think that is also really good to have, because when there are some use cases where, you want to use open source, or you might need a custom script for something. And so knowing a little bit of Python, I think, is really helpful as well. And version control is super important to know. I think also having experience with a modern cloud data warehouse, and it's also helpful to know some of the extract and load tools out there, like a Fivetran or a Stitch. Although because they are no code solutions, they're pretty easy to learn. So, I don't think they're insurmountable if someone has not used those before. But certainly, having the version control, SQL, Python, and experience with cloud data warehouses and how to manage those are top probably technical skills that I would include. And then I think when it comes to the soft skills, there's some there that are pretty critical. So I think one of the top ones that I always say, and I think this is true not just for analytics engineers, but also, data scientists or analysts, is like a curiosity. Your data, I said before, is inherently messy. And you're going to find things that are a bit unusual sometimes, or, I didn't expect that. And to be able to ask the right questions and kind of investigate and go down rabbit holes sometimes, I think is really, really valuable to be able to kind of troubleshoot and figure out what's going on in the data. So curiosity is super important. Also, I mean, this is probably true for any job, but communication skills, and understanding what business users need to do with the data and being able to communicate that back and forth. So, they don't know what's possible. And so you need to be able to talk to them in a non-technical way, and be able to understand what their needs are and kind of translate those back into, what is possible from a technical standpoint. And so to be able to communicate that, I think is really important. So those are probably the most important ones that I would always look for.
Yeah, those soft skills you mentioned with the communication and the curiosity, I guess those are inherent to the analyst, which is where the background, I imagine, for a lot of analytic engineers, that's where they come from, right? So they're used to knowing the data, finding out answers. Why does this look like this? We got to figure this one out. Or they're working with the business, the end users. What are you really after? What kind of a question are you trying to answer? That type of a thing. So, yeah, that makes a lot of sense. And I think the two soft skills you just mentioned would be good advice for any analytic engineer and any data engineer for that matter. That's for sure.
Yeah. I think they're really, really crucial for really any data role, to be honest.
Absolutely. What about learning resources? So what kind of blogs do you read? You recommend any book recommendations? Are there any conferences, boot camps? Is there a Kelly Burdine podcast coming soon? What's the background there?
Yeah, so there's a lot of great resources out there. I think we mentioned DBT, and DBT Labs is the company, and if they have a wonderful, I think it's called the Analytics Engineer Guide or something that they've recently put together. They also have a blog that's great to follow, but yeah, their guide that they put together, they actually pulled not just from their own company, but they pulled writers from other companies, other analytics engineers and data leaders across the community to bring together all these ideas and come up with this seminal piece on this is what analytics engineering is. And you can learn a ton just from that. And they also have some, they host a conference every year called Coalesce. I believe it's in December. This is basically the conference to attend. I think even though it's hosted by DBT Labs, it's obviously very DBT focused, but they talk about a lot of other tools there and processes and even things that are like, how do I convince my company that, we need more data resources or whatever it might be. So that's also a really great resource to go to. And then there's other blogs out there that I like to follow. There's one called Data Elixir. It's kind of a hodgepodge of various data resources and data topics in that blog. And there's one called the Data Standard, which is another good blog as well. I don't know how many books have been specifically written at this point about analytics engineering. I think a lot of people will point you to Kimball's old book about how to design a data warehouse, which there's an ongoing debate of how relevant that is with cloud data warehouses nowadays. But there's another one called, I think it's called the Agile Data Warehouse. That's a good book as well about kind of, modeling and transforming data for analytics use cases in kind of this modern cloud data warehouse environment that we're in. So those are probably the top places that I would send people to if they wanted to learn more about this.
Yeah, a little early for books, probably for conferences too, but I imagine they're coming. I think in the next 2 to 3 years, we'll probably be seeing more of both of those items there.
Yeah, I think you're right.
So kind of look into the crystal ball question here. How will the role of analytics engineer look 5 years from now? Got any thoughts on that?
Yeah, I mean, it's really difficult to say because 5 years ago, the term didn't even exist, right? So it's hard to say what it's going to look like. But the tools are certainly evolving, and it's I think it's getting easier to to be an analytics engineer. And I've seen a massive increase in the number of companies looking for analytics engineers in the last, I'd say 18 months, especially. So I think there's going to be a lot more roles opening up for analytics engineers. I mean, it's a very impactful role for a company because without this person, it's really hard to actually use the data to gain an edge, to gain a competitive advantage. And so it's really a role that kind of, I guess, magnifies what everybody else on the data team can do and what users can do. It makes everybody else more efficient. So we're certainly going to see an increase in the number of analytics engineers roles that are available. And then I think that when it comes to data quality, data testing, also data cataloging and being able to document, I still think we're like in the infancy of what some of that tooling looks like and what are best practices there. There's, I see new things out, weekly probably, but I expect that to change and become gain a little more clarity onto kind of what that looks like. I don't think we really know that yet. So yeah, if I had to guess, those were some of the areas that I might see change. But like I said, it's really difficult to know at this point.
Yeah, that makes sense. What's the next data role that you think will be created, right? So you mentioned the analytics engineering. That's pretty new. Any thoughts on what we could see within the next 5 years? If I
had to guess, I would say something like a DevOps for data. I've seen I've talked to a few people that are kind of in this role, but they're generally just called like data engineer or DevOps. But I think there's going to be a data ops person where there's somebody there to kind of maintain the entire data platform and the tooling for the data team, especially on larger teams. We've seen that DevOps can make engineers and deploying of software a lot more efficient in the software engineering world. And I think we're going to see probably the same thing with data because you can quickly, especially when you have a larger team, you're going to have a lot of different tools talking to each other, a lot of dependencies between those, and it can get it can turn in spaghetti real quick if you don't have someone kind of managing and keeping an eye on all of that.
Yeah, that's a good point. You're right that DevOps, or this idea of infrastructure and deployment, is the trend is have the developers or engineers pick it up, right? But as it becomes more complex, it may revert back to kind of a specialty role, right? I could totally see that, yeah. All right. Well, Kelly, thank you very much for coming on the episode. I really appreciate it. So, and for the folks out there, please subscribe, hit that subscribe button if you would, please, and be on the lookout for other episodes in the future.
Great. Thanks, Bob.